Hey folks, welcome back. In today's video, I'd like to dive a little deeper into this hybrid axle project that I have going on for the Midnight Panic truck. As you can see, I have an assembled housing over here with some knuckles on it. And over on this side, I have another housing that is all flanged up and ready to start putting some knuckles on it. But before I get into what it took to get to this point in the project or get this far along in the process, I thought I would maybe take a minute and go over a complete corner assembly and all of its components that come out of that, so you have a better idea of what I'm working with, what I'm using out of an original unit, and maybe go over some of the slang terms that we use for individual components. So I'll flip the camera around and we'll take a look at all these individual parts. As you can see hanging from the hoist here, I've got a complete corner assembly, as it's referred to. And this assembly has your planetary assembly here with your planet gears, a sun gear back in here splined on the outer axle shaft, and then the ring gear. This would be your hub assembly where your actual wheel bolts onto. These are the brakes, and then you have the knuckle and what is referred to as the champagne. Now in this whole assembly, you're going to use obviously the planetary, the stub axle shaft, this wheel hub assembly. The brakes are not used, the backing plate is not used. Inside of this whole unit, there's a spindle that we will use, and then obviously the knuckle and the champagne. This bolt pattern here actually attaches this whole assembly onto the original axle housing. And it is also used to attach the used components onto our new axle housing, as you can see right there. Now we'll go over some of these individual components, starting with the champagne. If we step over here to the table, here is the champagne, and it gets its name from its champagne glass shape. These are your kingpins, and your kingpins actually simply hold a tapered roller bearing assembly, and then the knuckle assembly itself here has the bores where the races of the tapered roller bearing actually fit into this housing. Now the knuckle is two-piece. You have the outer knuckle and the inner knuckle. If we step back over here to the assembled unit, you can see this parting line where the two halves of the knuckle are held together. The two halves of the knuckle are held together with a series of bolts holding the two halves together along with the kingpin caps. These retain the bearings and races within the bores of these two assemblies. Now, as I mentioned, we don't use the factory drum brakes that are on that complete assembly over there. Once the wheel hub is removed, this series of bolts here hold that drum in place. So the drum, the shoes, the backing plate, that whole assembly can be discarded. And then you're left with this wheel hub assembly, which has your wheel bearings in it. And then it has this outer ring gear here. Now inside of this outer ring gear, as I pointed out on the debraked hub, you have the planetary assembly itself. So you have planetary gears and a sun gear and the ring gear. That's where you get your gear reduction. The axle shaft turns the sun gear, which rotates inside of the planetary gears, which turn the hub via the ring gear. Now, I'll go into it deeper. The Pettibone works quite a bit different than most planetaries that people are used to seeing. I'll get deeper into that a little bit later on because it's actually really pretty unique. But I don't want to mix that in right now with just identifying the components. Now here on the table, I have this planetary assembly out, and you can see the individual components here pretty clearly. Planetary gears, there's 4 of those, or the planet gears. You have the sun gear here, and this actually splines onto the outer axle shaft on that set of splines right there. This carrier assembly actually splines onto the spindle. And this is the spindle that I mentioned earlier. Your wheel bearings ride in this area here, and when you spline that carrier assembly onto the splines, the spindle nut retains the carrier assembly and also sets the preload on your wheel bearings. Then you have this component here, which is referred to as the girdle, and it just ties all of this together, plus your axle shaft comes through this bearing to help carry it with the snap ring that retains it in place. Now, buried deep in the core of that whole assembly there, as I mentioned before, is the axle shaft. Once you get it out, this is what the stub shaft looks like. This is referred to as a Rosetta joint, and most of your standard four-wheel drives, you have a stub axle shaft, but they would have a U-joint in there, like a standard universal joint, which allows, that axle shaft to work at an angle in relation to the inner axle shaft when the knuckles are turned or when you're steering your front tires left to right. This works similarly, but instead of a cross and caps, this has a series of balls that work with this inner race and this outer bell. You can see it rolls around and allows that same movement when you turn the tires or turn the knuckles for that inner axle shaft to drive this outer axle shaft, this stub shaft, which in turn drives the sun gear, which is splined onto the end of the shaft, driving the Planet gears, which drive the ring gear, as we've covered before. This would be a factory stock inner axle shaft. This splined area here splines into this inner race. And this spline here splines into your side gears in the differential itself. Now we move over to, this is a custom axle shaft from SCS. Same splines here, which spline into the inner race of the Rosetta joint. And as you can see on this end of the axle shaft, these splines are a lot finer spline and bigger diameter because these shafts actually spline into the side gears of my 21-145 center section. So this is how we're marrying all of these parts together, is through this component here, which is a custom piece that I had to have built. Now, as soon as I got these housings, the width figured out on the housing, I was able to get an order placed on these shafts, and I sent that order in as soon as possible because I figured that was going to be like a 6 to 8 week wait for those parts. Turns out they had those things cranked out and on their way to me in less than a week, which is pretty amazing by today's standards. And here we have a complete assembly where I have that axle shaft splined into the Rosetta joint. And those parts will go in later on. So a quick recap, we have our housings. These are the flanges, champagnes, knuckles, inner and outer knuckle. This is where the spindle bolts on. Spindle assembly, planetary assembly, and axle shafts, stub shaft, inner shafts. Now we can get into how I've gotten to this point with these particular housings. Now these particular housings started out as just a standard commercial semi-truck housing. They are a 21-145 rear differential out of a set of tandems. A lot of guys actually completely fabricate the whole housing. And I believe some of that has to do with strength, some of it has to do with design. Personally, I think a lot of it has to do with the fact that these are really hard to find. You would think that as many trucks that run up and down the road, you'd be able to gather these up all day long. However, this housing normally goes for about twice what the center chunk goes for, which is really pretty crazy, but there's obviously a demand for it. I think a lot of them get damaged in wrecks. So it's really easy to sell these things. I was fortunate enough to actually do some trading for this pair of them, and I chose to start with the actual manufactured housing rather than completely fabricate the whole thing. I just thought it would be a little bit easier to start with, Now that I'm partially done with it, I don't really think that that was the right choice as far as ease goes, but I had them, and this is what I'm gonna work with. Like I said, these started out as just a simple semi-truck rear differential housing. After some careful measuring, I was able to figure out how much of each axle tube I could cut off, eliminating the spindle and making room for these flanges and getting the right width overall that I needed on these housings. So after I had measured a complete corner assembly and figuring out what overall width I needed, the housings were set up, and I just used a zip disc on a 4-inch grinder and very carefully cut the axle tubes as square and straight as possible. Now, even though I was extremely careful cutting these spindles off and cutting the tubes nice and straight, I still needed to get these flanges onto the housing as straight and true as possible. Now, to do that, I was going to need an alignment bar so that I could put all of these components in line and make sure that everything was as straight and square and true as possible. Now, I didn't have an alignment bar on hand, but I knew I had to have some material around here that I could use to do that. Turns out that my race trailer, when I originally bought it, had a lift gate on it, and that lift gate had two 10-foot long cylinders in each side, one in each side. So I was able to take those two cylinders out of the post assemblies for that lift gate and disassemble those two cylinders and I ended up with approximately 10 foot of 1.25" chrome shafting, which hydraulic cylinder shafting is inherently very straight. So I knew that that would work very well for an alignment bar for this project. Well, I've got my mess cleaned up a little bit here. Well, some of it's still in process. But I got all the stuff stripped off of those rods. I want to use about 4 foot of one of those for my alignment bar. The next step in this process is to build some slugs that will slide onto the bar and help hold all of these different components in place. And I kind of lucked out, so this seal head, or the gland, if you want to call it that, out of the end of the cylinder, happened to be big enough that I could machine the outside diameter down and fit into the carrier that this bar is going to have to slide through. Get you set up over here. You can see what's going on. So inside here, your side gears that the inner axle shaft will slide into. And I want to center all of my flanges on the outside of the housing. I want to center them up on this carrier. And I was able to turn about 25 thousandths off of this seal head and get a nice snug fit. So now I can use that, one on each side, and that will hold the bar. Once I drop this center section into the housing, how that one is sitting now, I'll be able to slide that bar right through the housing here. Then I'm going to take these drops. These are just basically wasted chunks of aluminum. And I'm going to build 2 slugs out of this one that will slide into that tube. And this slug here, I will build 2 that will fit in the end of this flange. Which this is a whole different story all by itself. I ended up having a little trouble with the footage of, explaining what I was going to do with these flanges on this tube. Fortunately, I was able to save the footage of the actual process, so I will show that and kind of explain what I did here to get this flange to fit on this tube. The inside diameter of this flange is actually 4 inch, and as I stated earlier, the outside diameter of this tube is 3.5. So there's a 1/4 inch difference per side to this actually fitting. And as you could see in the previous clip, this thing was just kind of hanging on that section of tube. What I ended up doing was cutting 4 1-foot long sections of tubing and setting them up on my rollers here. And then I set up my hands-free welding unit, my Hobart 235 there. I'm able to plug in a pedal, and that gives me 2 hands to roll this tube. And I've just got the MIG gun set up on a fixture here, so I can use both hands and roll this tube and weld it along. So what I ended up doing was welding 1 pass on each tube. I'd weld 1 pass, weld 1 tube, I'd set it off the side, grab the next 2, weld 1 pass, so on and so forth. Once all 4 tubes were completed, I would wire wheel the previous weld, set them back on the roller, run another pass. Continue that through 4 tubes, and again, wire wheel and start over. It would take about 6 passes to get about 3/4 of an inch, and then I ended up doing 4 passes height-wise. Once that was complete, I could set them up in the lathe and machine the outside diameter to get about a 4.5 thousandths press, so that they would fit fit correctly in these flanges. Now, to get the flanges on the tube with 4.5 thousandths interference fit, I would put the flanges in the oven at about 400 degrees. And by the time I got one of these tubes machined to fit, this flange was ready to go on. So I just set a spacer up here on the table, brought the flange out nice and hot, set it on the table, dropped the tube in, and let it sit. Once all 4 tubes were set in place on the flanges, then I set up a fixture with my rotary table for the milling machine, covered up good with a welding blanket, and then just run 1 continuous bead to weld that flange to that tube. So now those 2 pieces are now one. Now I've got this housing all cleaned up. All of the old drain holes are filled. Fill level holes are all filled, ground off, cleaned up. I've got plug welds, 2 per side, front and back. It's eight plug welds total. And then a nice weld prep ground here on the axle tube. And as you can see, I've got my alignment bar in place. You can see the pucks on the side of the carrier there. That's holding the bar in alignment. And then these pucks here, this one fits in the flange, This one here fits in the other end of the tube. The one in the tube here actually has an O-ring on it, and it's a pretty snug fit. That way I don't accidentally knock that puck out trying to get the bar slid in or out or have it move around. Should stay in place really well. This one here, you can see it has multiple steps. That's to fit that location there. So now with the bar in the housing, everything in place, I can slide these flanges and tubes in, get them all square, level, lined up where I want them, and get them tacked in place here. Then everything will come out. I'll pull the bar out, all the pucks, pull the center section out, and then I've got these bulkheads that actually fit in the housing right about here. And they fit this tube just like that. So now I'll get that stuff all set in place. Now you take that little bit of setup and welding and do it twice, and you end up with two housings that are all flanged up and ready to bolt some champagnes and knuckles on. Now these two housings are nearly identical. They're the same width, same flanges, same housings to start with. The only difference in the end product is how I mounted these flanges on. There's a very minimal difference. Now this is the rear differential housing here. And the way it's set up, the flanges are welded on so that when the champagnes are bolted on, the kingpins have zero caster built in. I know it's kind of hard to see and reference since there is no pinion in there and there are no kingpins mounted on there yet. But you can just kind of look and see, you can tell this pattern is pretty much squared up with the housing itself. Now if you look at this housing here, this is the front axle. This will be the front axle in the truck. And as you can see, there's a fair bit of caster built into this housing. So those flanges were welded on at 12 degrees off of zero. So the end result are your kingpins end up 12 degrees off from the pinion. And the reason that I did that is the front housing, the front drive line is a fair bit shorter than the rear drive line. And right now, the way the truck is set up, I'm working at the limit of the two front U-joints. So when I get the truck set up with these housings, essentially it's going to end up sitting taller or kind of, in a sense, more lift. So I'm going to need to roll that pinion up, and I don't want to have my caster rolled forward. So hopefully, if this all pans out and if I looked ahead correctly, I should end up with about 6 degrees of the pinion pointed up and 6 degrees of caster built into the housing, or still have 6 degrees of caster in the steering. So cross my fingers and hope that works out. Now to finish off this video, I'm going to go back almost to the beginning of the video where I had mentioned that the Pettibone Planetary is kind of unique when compared to, you know, more of a standard Planetary final drive. So what I'm going to do is I'll bring the camera over here and I'll go over and kind of highlight why I think that this Pettibone Planetary is, you know, somewhat unique and how it is, you know, very different than a standard Planetary final drive. I'll try and make this explanation kind of quick. This is the wheel cover off of an Axle Tech. So you can see this is the bolt pattern. This is actually part of the wheel hub assembly. When you flip it over, you can see these are your planet gears. The planet gears actually rotate with the wheel, with your tire. So your axle shaft goes in, drives the planet gears, which drive on a bowl gear or a ring gear, and that ring gear is splined onto the spindle. So keep that in mind. Bowl gear is stationary. Axle shaft drives the planet gears, which ride on the bowl gear or the ring gear and drives your wheel hub. And your axle shaft is driving the wheel hub the same direction as the axle shaft. Now you come over here to the Pettibone and you can see this is the carrier, these are your planet gears, and it splines onto the spindle, as I had mentioned at the beginning of the video. The ring gear itself is part of the wheel hub assembly. So you can tell right away that is considerably different than this setup here. And as a result of that, as your axle shaft drives the sun gear, which drives the planet gears that are stationary, drives the ring gear the opposite direction as the axle shaft. That's pretty critical information when you're getting ready to set up an axle to go underneath of a truck. Now I'm sure a guy could get more in depth on the differences between these two Planetary setups, but I just thought that it was pretty interesting that the stationary Planetary carrier of the Pettibone actually reversed the rotation of the tire and the wheel versus the axle shaft. So I just wanted to quickly share that just because I thought it was interesting. Now, as far as the rest of the axle content, that's going to come later down the road. I just want to get the truck running again before I spend too much more time really diving into the axle housings themselves. There's going to be a ton of reinforcement and fabrication, steering, link mounts, shock mounts, all of that type of stuff to come down the road. But priority to me now is to get the truck running, so that's the direction that I'm going to go. The next video you will see from me will probably actually be engine assembly, because I really feel like getting the truck running again is probably more important at this time. So yeah, thanks for watching and have a good one.